Hey guys, welcome back to episode 3 of the Abom Legacy series. This one is going to be a vertical output shaft machine from 10-inch 4140. I sound like I know what I'm saying again. I don't. Okay, so this one, lots of heavy turning. You're not going to want to miss it. Also, there's horizontal boring mill action. Again, not really sure what that means, but you guys are going to love it. You're gonna keep it going so you can see me walk away.
It's awesome.
You're gonna love it.
Yep. It's gonna be great.
There's another gearbox shaft that I'm working on. Just getting started. Similar in size to the last one that I did. It's 10 inches in diameter and 52 inches in length. This is a mod that I just made for the bore mill with these clamp bars up here, being some 4x4 tubing, 5/8 wall. That was some tubing that I had left over from a gearbox stand build that I had done, and I wanted to do those so that I could straddle the V blocks here on the bore mill and be able to clamp larger work pieces like this, make things a little bit easier, a little more heavy duty and rigid. So just getting set up to drill a center in the end of that over here on the board mill, and then we'll go to the lathe and start roughing it down. There's a shaft that I'm copying. You see we got a lot of turning to do on this end here. This is going to be very close to 10-inch diameter here. We got, I don't know, just roughly 4 3/4 on that small end there. And you see the badly rusted and corroded journals there. The first turning op we're doing is I'm establishing a round area for the steady rest to roll on, and then we'll come back to the face here and get it faced off and do some drilling and tapping both ends of these shafts. Normally they always get tapped so that you can screw an eye bolt in there for lifting these things up in a vertical position when dropping them into gears or bearings or into the housings or things like that. So we'll get this rounded off right here and do some facing. Now that we got that other end faced and drilled and tapped, I'm going to go ahead and turn a true spot here for the steady rest so we can flip this thing around and face it to the proper length, and go ahead and get our hole tapped on that end too. We're just going to plunge in and we're going to feed it. All right. Looks like I'll probably take one more little cleanup cut there. We got the shaft flipped around, set on our steady rest here, indicated. I've already touched the end, and I've also made sure that the tool is cutting on the center there. And we're going to start making some facing passes. I've got about 1 inch to come off the end of this on our total length. So our shaft length is 50 7/8, 50.875 inches. So I have the shaft pushed up against the chuck. It's a 36-inch scale. Alright, it's pushed up square against the base there. I should have about 1/8 of an inch to face off the end of this. All right, it's just over the 15-inch mark. I'm gonna flip it over, butt it up on the 36-inch rule. All right, it's lined up on the 64th line. So what that's telling me is that I have 140 thousandths to face off of it, or 9/64ths of an inch. I just say 140 thousandths. So I already know I have 1/8 of an inch, which is 0.125, and then you add 1/64 to it, which is 15 thousandths. All right. So I'll take that in 2 little light cuts, 2 16th passes to finish that out. So what I'm doing is I'm keeping my hand on the crank handle of the tailstock, and I'm applying pressure at pushing, helping push in the tailstock so that the tap is not pulling the weight of the tailstock. And now that it's pretty much all the way in there, I'll put a tap wrench on here and finish that out. So we're ready to start doing our heavy turning on this shaft, and I'm going to try out a sample insert that was given to me by the Kennametal guy that comes by here. He is the applications engineer and stops by every now and then and helps me out with some tooling and giving me a few sample inserts. So this is the info on this insert that we're going to use. Now I have used it once already You can see the discoloration on that one corner. That was from that EMD gearbox on the last SNS there, and it did good. But this one is molded and coated for heavy turning. So he gave me all the specs and just wrote it down on this sheet here. It's designed to run at 672 surface feet per minute. Feed rate, you can run between 19 and 24 thou per revolution, and depth of cut is 224, or you would double that, so you can take about, say, 450 thousandths off per pass. And so CNMG 432 RN is your chip breaker. This is the coating or the grade. KCP 05 is what that insert is. So take that information down if you want to try one for yourself, but we're going to go give this a test, and we'll probably dial in 400 thousandths every pass just to keep up with it. It's a little easier on the dial just to take 400 a pass. This is my turning tool that I always use. That's what it'll be going in right there. And to kind of give you an example on scale of size, so here is my turning tool that we always use typically. This is that ISCAR COMG tool. It gives you an example of the difference in size. So this is a 400 insert, and then this other one is a 600. And you can see the size difference there. Pretty big difference. So we're going to start with the Kennametal and see how it does, but I most likely will put this in there and do some of the cutting with this, because this is a great tool for heavy metal removal. Here's a little chart that I use for reference for figuring my surface feet or RPM, should I say. So this tool is recommended to run at 672, which is actually kind of fast, especially for a manual machine. And I have to adjust mine sometimes according to how the chips are popping off. So let's go ahead and figure 672 RPM. So we're going to take, for turning, we're going to figure what RPM is. So surface feet per minute divided by work diameter. We got a 10-inch piece, so we're going to go 672 surface feet per minute divided by 10 inches. All right, and then we're going to multiply that by 3.82 equals 256 RPM is what it's suggesting. We have a setting around 234 RPM, I believe. So we'll give that a shot and see how the chips fly. If they popping off everywhere at me, I'm going to change some things up. We'll start with a 20 thou feed rate. Go from 19 to 24. All right, we've already dialed in 400 on the dial. Let's go ahead and give it a shot. See the way it's popping back? That's just too much. It's way too much for me. I can't stand here at the machine and control it. CMC machine will probably be fine since it'd be an enclosure. We're going to have to just try to change this up a bit and see what it'll do. I'm not finding a combination that I like with this insert. You can see I've cut it a few times. I've changed the RPM and I've changed the feed rate. I have not changed the depth of cut because we're looking for maximum metal removal in the shortest amount of time, but giving us good chip control. I don't want chips popping off over here at me. I'm going to give you an example. We're running this, we drop it down to 186 RPM, and this is a 22 thou feed rate. All right, that'll get the job done definitely, but I'm not really liking it. I'm going to put my other tool back in there, and we're going to go with that. All right, let's compare real quick. Same setup, same RPM, same feed rate. 186 RPM. We're just going to come in here and touch off. Set a 0 on the dial here. Now let's see what it does. Perfect. See, it's throwing the chips down into the machine, not up at you. Keep keeps everything cool with our cool mist. Mainly the tool and the insert is what we're trying to keep cool here. I just went one notch up on the tumbler. We're running 25 thou per revolution. We were at 22. Seems like we're loading the machine pretty good here. I'm gonna back off on that feed. See how it sounds there. It just sounds like it's really loading up today. Okay, that's a little better. One notch down on the tumbler gear to 22 thou per revolution. Not quite as hard on the machine there. All right, so right here we're running 186 RPM, and I bumped it up to a 25,000 speed rate. So calculated, we're at 341 surface feet per minute right now. And it's definitely, don't forget your earplugs. Stuff's loud. Right there, we turn it, it's at 7 inches on the turn diameter, and we're going down to roughly 5.5. Moving on down the line, we got most of the small journals done. I still got 2 more large journals to turn in or get roughed in. Had it in the wrong feed selection there. Getting ready to turn this last journal, finishing out the roughing process on this end of the shaft, and I come up and touched it and noticed that the tool post was actually trying to push around. One is because of the insert, and I probably don't have this tight enough, but I was just going to point that out. So I noticed on the insert, which is, it was this side. Now I know you can't really see that very well. It doesn't look like it's chipped or broke or anything like that, but the edge is really worn. The corner and the edge, the cutting edge where it shears the metal, is really rounded off. So it's making too much pressure trying to get underneath that steel. So it's time to index this tool around. So we're going to use, I still have 2 sides over here that are good. We'll go ahead and flip that around and use a new edge right there. One of the nice things about this style insert is that it's a dovetail system. The insert has sort of this dovetail shape. The pocket is matching to that dovetail, and the clamp, once you tighten this screw, it actually sucks it back into the holder. It pushes it back that way, and the dovetail engaged in there won't allow that insert to lift out of there. All right, there we go. I've got this end finished roughed. All these journals are roughed in here. I'm going to go ahead and I'm going to slide the steady rest down to this journal here, and we'll reset the steady rest for this one. And then what we're going to do is take the shaft out, flip it around, chuck it here, get it indicated true here. It'll be sitting on the steady rest right there. I'll probably retool the center, and then we're going to rough in this end. There's going to be 2 steps here that get turned. I'll show you the shaft again just so that we're kind of on the same page here. So this is what we just did, and then this is what we're about to work on right there. Alrighty, we got her flipped around and indicated. We got her indicated here, and I got the indicator on that center that I've already cut. Let me get it moving. It looks like we got almost 2/1000ths of run out right there on that center. So we're running true on this journal right here with the steady rest. So I've shown this before. What we're going to do is set the compound here on 30 degrees, and I'll use a little criterion boring bar, and I'll go in there and I'll retool the center so that it's a nice true center, and then be able to put the live center back in it and go ahead and finish getting this end roughed out, get it roughed, and by the time I get this thing roughed here, it'll be quitting time. And we'll go home for the day, come back in the morning, and then start finishing it. All right, we got that back end roughed in. Still got to finish out the shoulder links and radiuses here, but we're going to go ahead and it's time to knock off. So we're going to let it cool overnight, come back in the morning and start finishing it in. Okay guys, we're getting back on this shaft. I'm going to start finishing it out, and we're using the CNMG 432 insert right there. That is one of my IS cars. This does excellent. It's my go-to. I've already made one pass across there, 100 thousandths. It's got a beautiful finish. So we're going to go ahead and get these diameters turned. I'm going to come in here with a radius tool, and there'll be radiuses on where all the corners are. I'm going to use my depth mic to get the shoulder distances accordingly, like it needs to be, and just going to get it finished out. Now I don't plan on filming the whole thing. I need to get going on this and try to get this done and get it out of the machine. I got a lot of work to do, but I'm going to give you some highlights along the way and kind of showing you, what I'm doing here. So I've got my sample shaft down there, mic'd and measured out, and I've got all my dimensions written down on the journal, shoulder distance and diameters, and double checked everything so I can look at that now and know what I need to turn this to. So I'll show you a typical cut. I had left that journal a 1/4 inch big, so we're going to take 100 thousandths. And just a pretty little chip. So there's the radius tool that we're going to use. That's a 1/4 inch wide tool, so that'll put a 1/8 radius in the corners, and that matches what's on the old shaft there. So we've already got it touched off to the shoulder. I got a 0 set on a dial over here, and I'm going to use my depth gauge. Alright, so 2.345, 50, 60, 70, 80s, that's 40 minus 5, so I got 35 thousandths to come off this shoulder. First thing I'm going to do is just, we're just going to clean it up. I'm going to get rid of that material there. And we're just going to blend that journal in. just like so. Okay. Now I took 5 thousandths. I took 5 off that shoulder. I'm going to do this again. I'm sorry that my hands are blocking. I'm trying to get in here and work, but all right, so it showed a total of 6 thousandths that I took right there. Okay. I moved in the proper distance that I needed. I'm just hand feeding this in. This is going to be our shoulder length, radius, everything's going to be blended at one time right here. All right, there we go. And it's undercut just a little bit under that shoulder, and that's exactly how the other shaft is there too. So I'm just going to come up and I'm going to do the same thing with that next shoulder there. All right, we got one end finished. These three journals are done. So it's time to flip it around and start finishing out this side. Doing the same thing. Finish the journal sizes and then come in and finish the radiuses. We got an 1/8 of an inch run out using the copper soft jaw so we don't mar anything up. Half a thou. All right, that needle's dancing around less than a half a thou right there. We're good to go. This is what a typical finishing pass is looking like. Now that's a 40 thousandths depth of cut or 20 thousandths per side using the 432 insert. Leaving a good finish on it. I got all these journals finished right here. I want to go ahead and put our radius here and here. So that's what I'm going to do. I'm going to show you some of that. I do not have this finished, but this journal here, I went ahead and skint it like 10 thousandths so that it was perfectly true with this to hold the steady rest, because this large tool, anytime you're trying to do radiuses, it's prone to chatter, and that will chatter going in there and trying to do that without some kind of steady rest. So let's get it cut. That'd be a 1/4 inch radius using a 1/2 inch round tool there. I've already got my shoulder links faced in where they need to be, maybe about 5 thousandths you can use to clean them up. It's already trying to chatter a little bit. I'm snugging up the top steady rest arm. All right, let me slow her down. So what I'm doing is I'm working both sides of it, trying to get most of it cut away. And then what I'll do is I'll slow the RPMs down to try to finish that out. All right, there we go. That one turned out real good. This one I'm gonna have to come back and revisit. I was getting a little bit of chatter there. I'm gonna have to move the steady rest down here further, closer to that. But that looks pretty good. We blended both of them really well. Alrighty guys, I've got the shaft finished. All the lathe work is done. I really wish I could have showed you some more, man. I was kind of under the gun to get this thing done and get out of the lathe. I've got jobs waiting to get into this lathe. So instead of focusing on the camera, I had to focus on work and get this done. But it all turned out pretty good. I was gonna point out, the last op that you seen me working on was these two radiuses here. And we got those blended out real well. You can see right here, I take some emery like this and I just roll it up, kind of like a cartridge roll. I just don't have any cartridge rolls for my air grinder here. And I'll roll it up kind of tight and I'll lay it in that corner with it spinning and just blend it out of there and do a couple different grits. There's 120, this was 50 grit, and then 120, and then use some Scotch-Brite. But we got radiuses in every corner. This would be 1/16 radiuses there. I'm sorry, 1/8 radiuses, that's a 1/16 radius. And then 1/4 inch radius is there. This is, I believe I used the 1/8 radius on that one. All right, but it looks good. Here, we'll spin it up. You can see it running. Okay, well, I'm gonna get it out of here, splash some oil on it so it don't flash rust on us, and move on to the next job. I got some other stuff I got to get done, so we'll come down here to the old shaft and show you. We got a keyway here, we got a keyway here, and we got some tapped holes there. So that's the mill work that we got to do. So here's the shaft finished up. We've got both of the keyways milled. That's a 32 millimeter key there. This is 120 millimeters on the end. And I just finished up this keyway here. That's a 1.5 by 3/4 deep keyway. And we made good use of the shop made A blocks there. I just didn't get a chance to get a lot of video of this. Just it's been too busy to mess with the camera, but I wanted to share it with you. The finished product here.